This one here, very annoyingly, is about graphs. So we had to draw a graph. Nevertheless, we're trying to find when is this true. For what values of x do we get this expression here producing something that's greater than 5? Now normally we would have written this if it was an equation we were graphing. This 5 would have been a y. So here it's really saying, look, it is greater than y, but the y here has to be more than 5. So what we do is pretend that it's the graph of y equals 4x plus 3. That lets us draw the graph. Now you've learnt this in chapter 1, so I hope you haven't forgotten how to draw your graphs. So you draw the graph of y equals 4x plus 3 in. But then we need to look at and say, well, hang on, there's y equals 5. We need to draw a dotted line across here and say we're only actually interested in above 5, for y is more than 5. That's what that says. Y is more than 5. So for values above that line there. So what x values give you values more than 5? Well, we can draw a line straight down to the x-axis here. Now, strictly, I should have used graph paper to do this, and that's what you really need to do. But you would draw the graph in, draw a line through 5, note where it intersects the graph, and then drop down to the x-axis, and wherever it crosses here, that's the value that gives you y equals 5. So since we want y more than 5, and at x equals a half, it gives you y equals 5. Well, we want more than 5, so therefore we want more than a half. So x is more than a half, or greater than a half would be the answer, and that's how we work it out using a graphical solution. Now, there's a whole bunch of these, but what we do after that is, in the next question, it asks you to do it all again except solve it algebraically. And so here, that one we just looked at in the graph is here, and so solving it, notice we treat it much the same as if it's an equal sign. There's only one little difference here that I'll show you in this one here. So again, we do the same thing. We leave the inequality there, the greater than sign, we take 3 from both sides, we then end up with this, then we divide both sides by 4 to give us x is greater than a half, and that's what we got when we did the graph, wasn't it? Which begs the question, why on earth would you bother to do a graph, all that work, when you could just simply do this? But I guess you need to know the two ways of doing it. Now this one here has a little difference in it, so I just want to show you that. Notice here we've got a negative x. So the subject that we're interested in, the x value, is negative. So the first thing we do is change that to a positive, and we do it by multiplying every single thing by -1. So -1 times that 1 now becomes a -1. -1 times -3x becomes plus x. The -8 becomes a +8, but notice what happens here. When we change the signs, this also changes its direction. So whereas it was less than or equal to, because it was a -3x, now it's a +3x, it becomes greater than or equal to. Just remember that. If you change the sign on the x expression here, then you must, or the x term, then you must change the direction of that sign. I don't know what you've got to do to remember that, but you have to remember it. Alright, so we did that, we ended up with this, added 1 to both sides, got 3x is greater than or equal to 9, divided both sides by 3, there was our answer. Remember that rule. Okay, changing the sign, you need to make sure that you reverse that sign around the other way. Alright, and the problem continues with these inequalities. Again, here, it's got an actual situation here of a second-hand car. You just need to think about what does it say. I mean, here is the problem here. She's going to buy a second-hand car. She opts to buy a second-hand one. She decides to pay, and there's the key, up to $10,000. If it's up to, then it means not more than, which means less than. So the price of the car is less than or equal to $10,000. That's how much she's going to pay for that. So that's the way we write that. And if she wants to buy it new, she wants it between $14,000 and $17,000. So $14,000 is the minimum. The most is $17,000. That's the sort of the way that you're writing those inequalities. Alright, same sorts of things here. The last part that we get to is substitution of formulas. And I'll just say here that there's another little fact you're going to need to remember. I hope that you've done this before. I just can't, I certainly haven't discussed it with you. Let's look at this. You all know this. 2 to the power of 3 equals 8. But perhaps you're not making the connection here so much. So we can also do it the other way. What's the cubed root of 8? Well, you know it's 2. Now, what I want you to do is notice the connection between these two things. Here's the base number, the 2. It ends up over here. Here's what would have been the answer, ends up here. And the power becomes the third root of that particular number. So here's some other ways of writing this. The square root of 9, normally there's a little 2 we would write here, but we just don't bother to write it. The square root of 9 can be written as 9 to the power of a half. The cubed root of 27 can be written as 27 to the power of a third. Note the way it's written. The fifth power, or the fifth root rather, of 625 could be written as 625 to the power of a fifth. Now that particular form, you need to be able to do that, is a way you can input these sorts of things into your calculator. You're going to need this in these next few questions. So I've used the calculator right throughout just to sort of show you the sorts of answers and what the input would look like. Very easy this. Evaluate these formulas. Just watch out, 2 decimal places. So they give you a formula. This has got B's and H's in it. They give you a value for B and H. So you just have to plug those in, replace the B and H with them, and work out the answer. That's all they're asking you to do throughout these. Just checks out your algebra skills though, so watch out that you just input correctly. All those answers are correct. This is really nasty in testing out your ability to use these powers. Look, I might just discuss this in class with you, but the worked out solution is written there. I don't think I'm going to talk to you very much more. Just about 21 here, rearranging formulas and things. You have to derive the formula. Then it asks you just to swap it around. So here it asks you for L as being the subject. So we divide by H, do it both sides by H to get L squared as V over H. Then we take the square root of both sides to get rid of the square here, giving us L is equal to square root of V over H, and so on. You can input these numbers, lots of use of brackets here, you have to really be aware of that. Look, alright, I think I might conclude that there. So that's exercise 3.1 support video. On the wiki is this particular file we're looking at and all the solutions to those problems.